okay, or add the corrections if you need to. So we have two review questions, the tangent line and the continuity question. So I'm just going to move continuity so I have some space. Tangent line equation. So the first thing I'm going to do is just write down the formula for the equation of a line. All right, so in order to fill in this formula, I need tangent slope and I need a point. Okay, two things. So I'm going to start with the point. The point when x equals 3 is just plug in 3. Okay, so 9, so negative 90 plus 18 plus 1 equals negative 71. Okay, so the point is 3 comma negative 71. That's the point. Notice this is just f of x. Okay? Now, I also need the tangent slope when x equals 3. Okay, tangent slope is the derivative. Okay, so think about those things that are interchangeable. F prime of x equals tangent slope. Okay, so that means that I need the derivative. So I'm going to start with the power rule, right? No long work, just the power rule. So that's minus 20x plus 6 plus nothing. Only pieces with an x actually affect the derivative. Okay? Now, if I want the tangent slope at 3, then I plug in 3. Negative 60 plus 6, so equals negative 54. So f prime of 3 is negative 54. That is the tangent slope. There's the slope, there's the point. So I'm going to put those two things together. Y minus y1 equals negative 54 x minus 3. Okay, there's the equation of the tangent line. So I also want to show you what it looks like in Desmos. Okay, so I'm going to graph the original and the tangent line, and I'm going to see if it looks good. I know what a tangent line looks like. Now I'm going to see if I actually have it. Okay. Let's see, I'm just gonna, okay, I'm gonna put the graph up here. Okay. I'm just gonna resize it so we can see everything. Okay, so there's my tangent line. So I'm going to start with the function f of x equals minus 10x squared plus 6x plus 1. Okay, so you can change the viewing window any way you want. Now notice that this point is really low. So I'm going to press this little wrench button and I'm going to change the viewing window. Okay, I need really low y values. Whoop. Okay, let's try that. So like maybe negative 80. And I like round numbers, so we'll go 10. Okay, now I have a picture that I can actually see. Okay, so let's try the point 3 comma negative 71. Oh, look, the point is actually on the graph. That's good. Okay, now I can even click label. There it goes. Now I'm going to write the equation of the tangent line. Y plus 71 equals negative 54, parentheses, x minus 3. There's the tangent line. Does it look like a tangent line? Yes. Okay, now you can change this viewing window kind of any way you want to make sure that it looks good. Okay, so I'll zoom back out a little bit. That looks pretty decent. Tangent line. Right, I'm checking my work. I did it algebraically, but I also wanted to see if the picture actually replicated what I thought I found. It did. Okay, that looks like a tangent line. What if you had done something silly like, oh, that's not a tangent line. Look at how the line is going right through it. Remember that tangent line has to bounce on the outside of the curve. Okay, what if you had gotten the right slope? Okay, what if you had gotten the right slope, but you ended up with the wrong coordinate? So let's put in like an 81. That's not a tangent line. So the visual is to help check the work that you found. Okay, so there's my visual. Looks good. See how my window, you can see everything? Okay, there's this, there's the point, there's the tangent line, and then on my paper, I've got all the work labeled. Okay, continuity. Let's check our continuity question. Okay, so question 2. Find k so that f of x is continuous. Okay, here's my f of x. K squared minus 112x for more than 2, for less than or equal to 2. Okay, so the first thing I'm going to do, just like I did on the previous page, I'm going to write down my definition of continuity. Okay, so the limit as x approaches, and I'm going to use 2 from the left, equals the limit as x approaches 2 from the right equals the point. The left, the right, and the point. That's the definition of continuity. That's what I'm going to start with, okay? I started with the equation of the tangent line, and I identified the parts that needed to be plugged in. This time, I need to find the left, and, all right, so notice those 2 pieces come from that part, okay? And the right comes from this part. Okay, now in order for this to be continuous, they better be equal. Okay, so the limit from the left is k times 2. K times 2. Notice how I didn't rewrite the limit statement because I've clearly identified which part is the left. I can plug in without rewriting it. Okay, now I need the right side. Okay, k squared minus 112, 2. Okay, well these 2 pieces are the same, so I'm only going to write them once. So 2k equals k squared minus 224. Luckily, I have a nice How to Solve Quadratics poster up. So I have more than 1k, so I'm going to try factoring. So I'm going to set it to 0. And I'm going to try factoring, which is kind of slow. But I'm going to do it. Times 2. Divide by 2. 50. Times 2. Divide by 2. I'm just making numbers here. 25. 28. Times 2. Oh, those numbers do it. Okay. There we go. There's my numbers. So minus and positive. K minus 16. K plus 14. Okay. Each factor to 0. K equals 16, K equals minus 14. Okay, find K so that f of x is continuous. Demonstrate your solution in Desmos. Actually check to see if it's continuous. I still see people writing, so I was going to wait. Okay, here we go. So, new graph. Okay. So, I'm going to graph the function. All right, so this gets a little tricky here. So, k squared minus 112x. Okay, but it's a piecewise, so you have to include the domain. X is more than 2. Okay, and then you're going to add a slider for k. Now, I can't see anything yet, so I'm going to zoom out. See if, do I see anything? No, not yet. Okay, let's put in the other piece. Okay, y equals 2 kx. There's a graph, okay? And I'm going to add the domain. X is less than 2. Okay. There's my piecewise equation in 2 parts. Now I can see the green part. I can't quite see the red part yet, probably because of that 112x. So I'm going to come here and notice that the k values are supposed to be 16 and 14. So I'm going to click here. Click. And I'm going to go negative 20 to 20. And I'm just going to step by 1, which are integers. Okay? All right. Oh, there's the other piece. Okay, so as I move the k... Oh, whoop. Nope, not tangent. Continuity. Notice that as I move those k values, look at that, negative 14, the left side and the right side actually meet in the same place. Okay? So let's say your trouble's finding the viewing window. So I'm going to look over here. Notice the coordinates. Okay? Where is the actual point where they meet? When x equals 2, the point f of 2 equals, okay, kx. So it's either going to be 16 times 2, which is 32. So we're going to have a point here. Or it's negative 14 to negative 28. Those are the 2 places that the graph should meet, right? You're trying to like see it. So you need to know where you're looking. So now we're going to go and we're going to look at those specific points to see if the graphs actually touch. Okay, look here. Oh, that is the right point. It says undefined because of the, where's the equals? Let's add an equals. There it goes. Equals. There it is, 2, negative 28. They actually meet. Okay, so now I'm going to scroll my k value, see if I can zoom out. Okay, okay, zoom out. All right, I'm going to move my value. Look, not continuous because they don't touch. Not continuous, not continuous, not continuous. Wait for it. Oh, it's getting closer. Continuous. They actually touch at 232. Okay, so I'm using Desmos to check the continuity.